is a perspective view as if we were on the ground. There's actually an orbital image, but we project it as if we're on the ground. This will show you a little animated GIF that shows you the time sequence of these features. So on the left is a black and white image. This is Pallikier crater, and it's all along the, and then in the northern hemisphere, we've seen quite a few of these now in Acidalia plain. If you go to the next one, this just shows Mars and its orbit around the sun. And this is to explain a little bit about why we see these at different times in different places.
So if you see in the slide, there's an orbiter shooting rays down, and that's basically what spectroscopy is. An excellent example to illustrate the theory behind spectroscopy is at about 2.14 micron. It's another deep, which means light is also being absorbed at this wavelength. And you can see arrows pointing to some faded streaks flowing out of the crater wall. This is in a slightly different location in the southern hemisphere of Mars. For example, if you take a glass of liquid water here on Earth, the water will remain in the liquid form until you hit 0 degrees Celsius, when it will start turning into ice.
I will now discuss the second major implication and then discuss some of the broader significance of our findings. So, perchlorate salts have a special capability pertaining to the absorption of atmospheric water through a process called deliquescence. Basically, if the humidity in the Martian atmosphere gets high enough, perchlorate salts will absorb the atmospheric water until the salt dissolves and forms a liquid solution. This is one possibility for explaining the formation of RSL. So this sort of physical process can explain the features that we observed here. The discrete darker patches observed in this image may be formed by deliquescence. Our detection of perchlorates at RSL sites are shown here in blue. So water, as I'm sure many of you have heard us say on multiple occasions, is an essential ingredient for life and may decrease the cost and increase the resilience of human activity on the red planet.